we want to solve question number 2, which is on circle theorem. So in the diagram, O is the center of the circle. Angle OQR is 32 degrees. Angle MPQ 15 degrees. We want to calculate angle QPR and that of angle MQO. So let's see how best we can solve this problem on circle theorem. So let's see. So now when you look at this, the angle that you want to solve is this angle QPR. So this is angle QPR is located here. That's angle QPR. So we connect this angle to other parts of the circle. We also check which chord is making that angle. It is the chord QR, which is making this angle at the circumference. Another part of the circle where QR makes an angle is at the center of the circle. So we know the theorem that connects angle formed at the center by a chord, by the same chord at the circumference. We learned that the angle at the center is twice the one at the circumference. So that is what we are going to use to solve this. So it means that if we know the angle formed here, we just have to divide it into 2 to get the one which is here. Alright, so let's go. Now we want to use the triangle QOR to find the angle, because angle QOR is inside the triangle OQR. Now triangle OQR is an isosceles triangle because two sides are equal. A line from the center to any part of the circle is a radius. So this is a radius, and it is equal in length. So triangle OQR is an isosceles triangle. Therefore, the two base angles are equal. So angle OQR, which is 32, is the same as angle ORQ, which will also be 32. Therefore, angle OQR, angle OQR. So angle OQR is the same as angle ORQ, which is what? 32 degrees. Now angle sum in a triangle is 180. So we have 32 degrees plus 32 degrees plus angle QOR will give us 180 degrees. So this, when we simplify, will give us 64 degrees plus angle QOR is equal to 180. This implies that angle QOR is equal to 180 minus 64 degrees. Therefore, angle QOR is equal to 116 degrees. So angle QOR equals 116 degrees. Now, angle QPR, is half of angle QOR. Alright, so let me clean this side so that we can have more space. This implies that angle QPR is equal to half of 116, and that gives us what? 58 degrees. 58 degrees. Therefore, angle QPR is 58 degrees. It's 58 degrees. Alright, so let me write this one here. So this is what? 58 degrees. Okay, now let's go to the second part, which is we want to find angle MQO. So let's locate angle MQO. MQO is this one. From this line to this line is the angle MQO, and that angle is inside triangle MQO, right? So let's see how best we can solve that. Now again, triangle QO is what? Is isosceles. Okay, it's also isosceles. So base angles are equal. So the angle that you find as OMQ is the same as what? MQO. Angle MQO. Alright, so let's see how best we can solve that. So if we know the angle which is formed here, this one, which is MOQ, then we subtract it from 180 and divide it by 2. Alright, so now let's find the angle MOQ. Angle MOQ is what? 2 times angle MQP, angle MPQ, angle MPQ. Why? Because it is the chord MQ that makes this angle 15, which is the angle MPQ, which is 15. So this same chord is making an angle at the center here. So twice this angle is this angle which is formed here. Therefore, angle MOQ is equal to 2 times the 15 degrees, and that gives us what? 30 degrees. So that will be 30 degrees. Now angle sum in triangle MOQ is 180. So we can let MQO to be x, which is equal to OMQ. So we have x plus our 30 degrees will sum up to 180. So this gives us 2x plus 30 is equal to 180 degrees. Okay, so let's clean here and say this. So we have 2x is equal to 180 minus 30. We have 2x equals what? 150. And we are looking for x. So we divide through by 2 by 2. X is equal to what? 75 degrees. Now our x is the same as the angle MQO. Okay, therefore angle MQO equals 75 degrees. All right, thank you.